Okay, we're back with another edition of PreCalc, this time on a Wednesday, finishing up the 7.3. This is some partial fraction decomposition. I actually think a really fun application that we're going to have here. So, for instance, we could have this fraction here, x plus 7 over x squared minus 6 minus x minus 6. And we would like to chop this up into smaller pieces so that in the future, specifically with calculus and future courses, we could actually do something with this. Let's take a look and see what I'm even talking about with this. So for instance, I think a lot of us would be just fine being able to factor out that denominator, making that x minus 3 and x plus 2. But the goal of this is to break it down even farther and make this into two smaller fractions who have the denominators x minus 3 and x plus 2 individually. So the question now becomes, well, how do we do something like this? And let's take a look at specifically this section here. If we take that, we don't really like dealing with fractions as they are. So how can we get rid of the denominators or kind of just make them into the numerator portions? Well, we could multiply both sides by the least common denominator, which is actually going to be this big thing, the x minus 3 and the x plus 2. So if we multiplied it on this side and this side, the right side, we're just left with this x plus 7. Or on the left side, on this right side here, when we multiply the first term, the x minus 3's are going to factor to 1, leaving us with a times x plus 2. If we do it with this b term, we're left with just the b times the x minus 3, since the x plus 2 in the denominator and this one are going to factor out. So we're down to here. And at this point, there's a couple ways to solve this. I'm going to go through and show you my way, and then the way that relates to the section that we're in. So when we're here, I'd like to solve for what a and b have to be, which means I would like to eliminate one of them here. Knowing that multiplication is happening, I think a times 0 would be great here because that means we're just left with the b term. What could we let x be to make this whole first term here 0? And we think we're adding to, so let's let x equal negative 2. If that's the case, we have negative 2 plus 7 equals a times negative 2 plus 2 plus b times negative 2 minus 3. So we have 5 equals a times 0 plus b times negative 5. So really all we're left with is 5 equals negative 5b, and b has to equal negative 1. That's good. But we also need to solve for that a term. So if we want a around but not b anymore, we could let x equal what term to make this b go away and be 0. Specifically, we want that factorization to be 0, that binomial. So let's let x equal 3. Leaving us here, which is 10 equals to 5a. A is equal to 2. Since we've solved for what a and b each have to be, our factorization here from the original statement we have to rewrite. This would be the same thing as a was 2, so 2 goes over x minus 3, and b was negative 1, so negative 1 goes over x plus 2. And if you actually added those together with some common denominators, you'd see that they are in fact equal to one another. But there is another method to go through this, and I want to show you that, which is how it actually relates to this section. I'm going to just start at this step here. So we had x plus 7 equal to a times x plus 2 plus b times x minus 3. Let's actually multiply that out. Ax plus, I'm going to write it as 2a plus bx minus 3b. And we could rearrange this. So I'll put the x's first, the non-x's second. What we should be thinking here is that ax plus bx has to equal 1x. Additionally, we have to know that 2a minus 3b has to equal 7. So from here, we could technically set up a system of equations. So ax plus bx has to equal x, and 2a minus 3b has to equal 7. How I'd really like to think of this is I don't like those x's in there. That's just a plus b equals 1. And what do we have here? 2a minus 3b has to equal 7. Going through and solving this, we could do like we did back on Monday. We could multiply this first row by 2 and subtract it from here. So we're left with a plus b equals 1. 2 times the first row gets us 2a. We subtract it there. There's nothing. 2 times the first row here is 2b. We subtract it here. Negative 5b. 2 times the first row subtracted here gets us 5. Oh, so from here we have b equals negative 1. If b is negative 1, that means a equals 2. So we can do that same process here, and this is showing how it ties into all of the work we've done in chapter 7 here with all these system of equations. Okay, I personally like the first way better. I'm going to do one more example and then get you going with some more work off of this. Okay, this one looks a little bit more complex because there is a little bit more to it. This is now with repeated linear factors. So I will want to factor this denominator, not just rewrite it. I can see that x term is going to come out. And then we're left with that quadratic, which we can see is going to factor as well. Into 2 different x plus 1s. So we could rewrite this whole thing down here. Like this. And now if we're going through that same process before, we could say this is like a over x plus b over x plus 1. And we're finally going to have one last term, which would be over the repeated factor. Let's say this was to the third power, we'd have another plus d over x plus 1 to the third. You keep going up powers higher and higher until you reach the one that you factored to. Okay, now that we're at this point, let's multiply by that common denominator here. So we're multiplying this whole entire equation by x times x plus 1 squared. Over here on the left-hand side, we're just left with that numerator. Over here, just the x's are going to factor out, leaving us with an a times x plus 1 squared. With b, just one of the x plus 1s is factoring out. So we're left with b times x plus 1. And then finally that c term, just an x is left because the squareds factor out. Okay, let's be smart in picking what we want our x's to be. So looking at this first one, if we let it equal -1, this is going to be 0. This will be 0, and that leaves us with just the c term. So that's probably a pretty good one to start with. Let's let x equal -1. 5 minus 20 plus 6, because the 1 becomes 1 here, becomes a -20. Right, we have a 0 here because this is 0 times a. We have another 0 here, and then finally we're left with a -c. 5 minus 20 plus 6, we're left with what? -9. So c equals 9 is what we're looking at here. Great. Okay, that's with x equal -1. What's another creative one we can pick here, which is going to make a lot of them go away? We're going to use -1 here, same thing here. What about this x term? If we let that equal 0, let's see what's going to happen here. We have just 6 left over here, right? 0, 0, 6. So this a term becomes just a times 1. This one becomes a 0. This one becomes a 0. So we're left with a equals 6. Great. So we are most of the way there. But if you're noticing, we've run out of things to let x equal that are going to eliminate the other ones, because we need to find something that will solve for b that will eliminate these two. If we're stuck at a place like this, let's let x equal some other number. So here, let's let it equal 1. So we could say here, 5 plus 20 plus 6, that's plugging in the 1, equals 2 squared, that's 4a, plus 2 times 1, yep, that's a 2b, plus c. And we have 31 equals this whole mess here. You're saying, well, that's not super helpful. But we already know what a and c are going to be. So we can plug that in. So 24 plus 9 is getting us 33. So how would I write 33? And at this point we subtract that over, and b is equal to -1. So our final answer that we're looking for here is, how am I going to write this? So a over x, or a was 6. B over x plus 1, we found out b was -1. So notice I write plus still, and I write that -1 in the numerator. You could pull the negative out. I just like putting it in the numerator. And then the c is going to be. So that would be our final answer here. Nice. Okay. So let's talk about what questions I want you to do here. So we're in 7.3, and I want you to do 55 through 68. I know it seems like quite a few here, but this I'm actually going to be nice, and I'm going to call this the bonus for this marking period. A lot of you have been asking for it. This is what I've decided. If you can show me all of these, send me an email with these, you're going to be good to go. However, for me to give you the bonus, I need to see all your homework from sections 7.1 to 7.3 in addition to this. The others are just what it should be. This is our new stuff. And I need pictures of the homework sent to my email. So that's jjohnson4 at SyracuseCitySchoolDistrict.us. So if you get all of these done, I will give you 5% on that third marking period grade. But I need that other homework done as well, since that is still work that you need to have completed. And let's set a due date on this, that I need this by Monday at noon. I don't know what Monday's date is, though. So whatever Monday is, let's see, we're at the 8th, 9, 10, 11, 12. So that's Monday the 13th at noon if you're looking to get those bonus points. Okay, pre-cal class. Stay safe, take it easy, and I'll talk to you all soon.